Hi, everybody. We're gonna kick off what I'm sure is going to be an amazing lecture. My name is Theodore Sparopoulos, and I have the pleasure of directing the Design Research Lab with an amazing group of colleagues. And as part of our thesis review, we had the first of 2 days today, we invite someone from our community, either a guest critic, distinguished designer, colleague, graduate, to offer what we call as a kind of keynote lecture. In some sense, in a spirited way, the talk is really to build on, I think, larger issues of design and to share experience and really the role that design, and in this case engineering, is playing in terms of really addressing a lot of the kind of social issues about how we think about the built environment and how we consider the role of design in the everyday. Albert Williamson-Taylor really doesn't need much of an introduction to the DRL community. He's been our distinguished technical tutor and technical lead from AKT II for over 10 years. And we've had the pleasure of having a lot of these insightful comments and conversations about the role that architecture and design and engineering plays in society. For all the students, all of the projects are kind of touched by the team from AKT in terms of really engaging a synergy that doesn't look at architecture and engineering as separate and the kind of entities, but really as the synergy between those two actually giving over new ideas and new concepts for a lot of the challenges that society faces. Albert has had over 30 years of experience, really working at the forefront of really engineering practices, design, problematizing projects across the globe with very different kind of audiences and very different agencies in terms of dealing with complex problems and trying to find solutions to really difficult challenges. And I think when it comes to sustainability, when it comes to creatively rethinking the city, many of the architects turn to Albert and the team at AKT II to help shape, I think, a lot of the ways that one starts to think about solutions within the space. So I couldn't think of somebody better at the moment to really speak to a lot of the challenges that are ahead, and to be able to offer and complement a lot of the experiences and the things that we try to do within the program, and to foreground that in a way that makes it accessible and also speaks, I think, to the importance of really thinking about design and engineering as a way to create solutions for a better tomorrow. With that, I will keep this quite short and really just thank Albert for accepting the invitation. He doesn't do many lectures, not because he's not asked, but because obviously he's working across so many different aspects of design and project development that we're very grateful that he accepted the invitation. So Albert, I will pass it to you, and we will have questions and answers at the completion of the lecture. There's a raised hand function because all of the microphones are muted. So please raise your hand and Albert will be happy to answer any questions at the end. So with that, Albert, thank you, and the floor is yours.
Thank you very much, Theo. Thanks for the introduction, and good evening to everyone. I know most of the students have been busy trying to get your presentations done for your great speech, and hopefully it's all going okay. Thank you for inviting me to sort of give a talk in terms of my experience. In this sort of lecture I'm going to give, I like to draw on my design engineering and infrastructure experience, exploring how we challenge preconceptions and share vision for design and engineering moving forward. We're in very difficult times at the moment, not just in terms of the political situation, in terms of the rise of popularism, and also the fact that we're going through a global pandemic. It is important that we really focus in terms of how we move forward. And that has got both us in the engineering fraternity, I'm sure in the architectural, really thinking very hard of how we move forward. There are also some critical issues that's come up recently. There's the issue of race, climate change, the environment, and globalization. These are not fully recognized by the built environment, which forms probably the largest employers of designers and engineers worldwide. Our industry, this industry, doesn't yet reflect the contribution nor the suppressed potential of many demographics. I think it instead sort of sought to isolate design. There's this issue of trying to isolate design from the human experience and the social circumstances. There's no dialogue going between those two. The architectural engineering fraternity does focus on knowledge and research, which is something that the DRL and the AA does very well. And we need to continue, because for me, this is one of the very few ways we can address some of these vital concerns. This presentation I'm going to give, I'll try and deal with some of these design drivers through the body of work and the approach we take. And I believe it will reflect on some of these issues which affects all of us. I'll actually start just giving a bit of a background. You can see I've been deteriorating for a long time. I was born in Bethnal Green in East London, border between the 50s and late 50s, early 60s. I grew up in Sierra Leone and Nigeria, traveling across West Africa, because my father came to the UK to do architecture. He ended up becoming a surveyor, long story. But he was one of the first Black expatriates to be sent through after independence between the countries of Nigeria, Sierra Leone, and even Ghana. So there was a lot of traveling. Came back to Bristol in the mid-70s, and then went to Bradford University. And one of my passionate things was Taekwondo, which I enjoyed enormously, even though I was also trained to be an engineer. And back then in the late, actually I went to Bradford in 78. Just to give you an insight, I was the only Black engineer in the department. It gives you an idea of some of the challenges one had to deal with. But having said that, I had some fantastic tutors. So the choice was, do I carry on doing Taekwondo or do I go into engineering? I chose engineering. Having said that, I was in my association, I was British and English champion for about 5 years in the lightweight division, and I attained the 5th Dan in Taekwondo. AKT as an organization, for us, started from a position of collaboration, research, and pure engineering. And what I mean by that was by actually dealing with some of the challenges that actually consumes the industry in a very negative way. So we started as an organization, and as soon as we started from a position of pure diversity in terms of education, race, positioning, whether you're from different backgrounds, and that has stood us in a very good stead in terms of moving the practice forward. The family, this was taken a few years ago, a couple of years ago, but it's pretty much still the same. it shows you the demographics of the age group in the organization. And for us, London is our doorstep, it's our background. London to us is, and to me personally, is an international city. And what that means is that there's a constant amount of change, both politically and socially. And that has a huge impact in terms of its influence in the design and in the engineering world. So London is basically our backyard and our doorstep. But having said that, we see the international market, and in international areas is where you've got opportunities to even push the design and the engineering much more aggressively. To make this happen, for us, working with the institutions is absolutely important. And over the years and up till now, we work very closely, as I said, with the AA. We run a unit at Harvard, which my partner does, Cambridge, Bath, the Can Development Network. We're involved, the Design Council, TRADA, and the NLA. What we try to do is to actually understand some of the drivers that actually affect us in the industry. The research and the academic side is very important, but also understanding how that fits into the realities and the politics of what we do. And all in all, that also brings you to actually interface with both the economics and the politics of not just the projects you're dealing with, but also the nation and either the community you're dealing with. For us to get this forward, as soon as we started as a practice, we actually created a research team, a PAT team. And that team works very closely with a lot of the institutions we work with. But in terms of doing that, computational approach is very important. And for us, we try to use it to map out some of the issues that actually, some of the drivers and issues that we need to deal with in terms of being able to help both the architects, the designers, ourselves, and the client, importantly, to achieve the vision which we all aspire to. Now, this is a slide which I find very fascinating, but it's a very simple slide, but it actually tries to collate some of one's thinking in terms of moving forward. We need to understand history is very important, and that will be relevant in some of the slides I'm going to show, because without the understanding of how historical engineering and historical data has been processed to allow space and form and things to happen, you cannot move forward. And the present situation we're in, I'm having reports on some of our projects where, they've got staff issues, which we all have due to the pandemic. We need to understand people. We need to understand people around us. We need to understand the politics. And we have to constantly battle to ensure that beauty and vision are not suppressed due to other drivers, which can be economical drivers and which can be political drivers. Because creating the vision in terms of space, we want to work with resource, climate change, all of those issues are what creates the kind of structure you need that will last the test of time. And we need to synthesize this in terms of how we look into the future. This slide for me is a very important one because these are some of the early works we were looking at back in 2008, where we were trying to take computation beyond just geometry. And we were offered a project in Reading to do a footbridge. And the constraints on the footbridge between the canal, a highway installation was very complex. And what we then did was to actually create something where we were able to install some of the drivers and do that by actually allowing it to increase the physical form of that space from a pedrouting. And from that, we then developed a bridge. Unfortunately, it never got built, but it was the starting process for us. And since then, we've moved on. And the number of projects, this is to give you a breadth of a number of projects which have been involved, in which my team and I have been involved with at AKT. And we cover all the sectors. And with that comes a huge amount of challenges. Innovation is very important, and we strive, and I would encourage the students having, after finishing at the AA, not to see research as just part of an educational experience. Research is the key to the kind of lifestyle and the kind of issues we're trying to resolve. And without research, and that research allows you to assess the risk that's involved and allows you to mitigate it and move forward and think about the future. So for us, new materials, and we test them, not test them just in the lab, and not test them in terms of the form of the physical properties, but test them in terms of how they perform. And how they perform, how they create the spaces, the color, lighting, the carbon footprint, and installation. So here you can see a few. Engineering is something we now do very, very well. I think we were one of the first organizations to actually start it in a very positive way, where we deal with intervention, not just restoration. This is intervention, giving buildings that supposedly going to the end of their lives another 60, 100, 120 years. And I will go through some of this. This is just a slide, a 30-second slide, which actually shows the breadth of some of the projects which we've been involved in, and all across the globe. And most of these projects are actually real projects, which have either happened or are happening. So for us, it is important we do not see cost or the economical situation of a project as a barrier not to develop and push the boundaries of the projects. And innovation in industry is the hardest bit in our profession to do, because you have to be able to communicate in terms of drawings, whether the makers may only understand 2D drawings and may only understand a different form of communication. It is for us, the designers, to come to actually amend and adjust our communication skills to make sure they understand what we're trying to do in order to make things happen. And if we have to then adjust the design and adjust our thinking and adjust our process, we should always do that. And again, that will come through. Design philosophy is very important. As designers, we need to have integrity, and we need to have a position in terms of issues that affects our planet, the environment, sustainability, which most designers take on board. But we also have to have a position politically, because politics and design and space comes together. You cannot differentiate them. So, but we have to do it in terms of how we're trying to improve the human experience. And for us as engineers, it is important to understand how the process of what we do and how we create the spaces we do and what we need to go through, how it's what historically and where we believe the future is going to be, because it is that future that allows us to actually innovate in a direction where we feel is positive. And for me personally, I think the future is incredibly bright in terms of innovation, because we've actually come through from a process where mass, the arch, the pyramids, where mass was the actual method of analysis, going right through now where we're expected, to carry the elephant or two elephants and a windmill on top. And yet we are part of the family that is actually looking at how you deal with some of the issues of logistics. And it's no longer worrying about the logistics traveling on land. That is well and defined. The mode may change from going from fossil fuel to electrical and electronic power, but then flight is probably the easiest mode of traveling once we can deal with the logistics. And also robotics. We should not be fearful of robotics. And I think the reason why we also got to be understand where the future is going and the politics of the human working life and experience is the fact that even as we're coming out of, well, I hope we're going to come out of this popularist and political position. I think as we all try, every nation is trying to improve their industry. The industry of the future is going to be based on robotics. It's going to be based on AI. And as we develop as designers and engineers, it is important to understand that pushing the technological education of the population has to continue. The way we all use our iPads, what we design, our lifestyle, all of that needs to carry on moving. So the way we accumulate or the way we process design has to be based on both logistics and also robotics. And the rate of innovation with artificial intelligence is moving forward. The computer, in the next few years, the processor is going to be in every single element we use in our everyday life, not just the electronics we deal with. But then the ideas come back to the fact that you need people, you need errors, you need ideas, no matter how stupid they are, you need to be able to process those. And the electronic approach to doing that, and I'm sure there's a number of people, we've all experienced the fact that in this lockdown, it's been very, very difficult to deal with interactive design because the infrastructure is running way behind the processing power we consume in our design process. But again, that is something we need to be cognizant of. Just to in this section, just to actually show you some of the research we've been doing at AKT, and we introduced this app literally a few months ago, last year, and the whole before the pandemic, and the whole idea is to actually allow us as and also our friends and the community to actually be more cognizant of the environment we live in London, in central London. And this app is available everywhere, and it actually deals with the issue of not just architecture, the environment, and air pollution, and we try and see whether we can make sure we understand not just how the boroughs or how London deals with all the issues that affects us. For me personally, my career in engineering, which is still going, it's always been how do we test the boundaries? How do we test the boundaries in terms of space engineering? And from the, since I left university from the 80s, the early 80s, been involved in every single project I've been involved with. I always try and see, how do we push the material, the client, the form, the people around you, how do we push them a little bit forward in terms of their understanding and our understanding of what we're trying to create. And these are some of the early projects I was involved in. The floating bridge in West India Dock. And I can remember the conversation that was being had, that how can you do a floating bridge in a tidal canal, an opening, not just a floating, but an opening bridge on a tidal canal that changes its level by a meter. Yes, there was a solution, submarines. And by actually tying the pontoons, putting them in tension into the water, we're able to create an opening section and be able to deal with the dynamics within acceptable levels. Plaza 535 was one of my early projects with glass, with Pilkingtons, where we did a tension glass roof and a tension glass wall. And at the time, it was fascinating. The whole industry was very much into the risk involved in doing an atrium of this scale. And we went on to do the one in the Hilton Hotel in Terminal 4. But it was important to understand that every single bracket was cast and made and tested, because they did not exist as a bespoke element back then. And the Sackler Galleries for me is one of the, one of the first commercial glass there, which was done. There was no laminated glass. It's just pure float glass, no toughened glass. But then by actually encapsulating each panel into a very stiff stainless steel enclosure allows us to then test it to make sure they collapse. So it was actually designed from a testing regime rather than from a mathematical approach. But this again is pushing the boundaries of the materials so that you can create beautiful space. The original space was a dead, tired building, and to bring it back to life, creating a very simple glass exclosure at the top with a portal frame without any eaves members, so that maximum amount of light into the space. 27 years later, is still a beautiful space that everybody enjoys. And this is one of the early projects I was very proud of, where we were talking about sustainability. And I can remember having a conversation and the argument about creating a dome. This dome at the top of this, and the dome is actually made from softwood, and it supports a steel structure that then supports the glazing and the actuators. And we were told absolutely clearly that you cannot use timber to support steel of that scale. And we said, of course you can. And you cannot use white wood, soft and sustainable wood. But that's exactly what we did. But we had the support of the architect, First and Partners, in terms of allowing us to push the direction of this. And then we created the first step ramp, which we had to get the local authority to run up and down it to say, by doing a sample to say, yes, it can be done. And it creates communication. This was done way before the one at the GLA. That allows you to actually run up and down and allow the students to communicate in a faster mode than actually to go through the lifts. And again, it's a concrete building. And it was done by coming back to early geometry. This was a spiral geometry which we used that allowed the fabrication to be done with hidden wells seamlessly. Again, back to research, working with the incredible team. Abbey House, I put this in one of the early ones. This was more to do with politics, working with English heritage. This was a building that was used for some of the books in terms of Sherlock Holmes. And the clock of the bell tower is locally listed, and we were told you cannot bring it down to develop the building. And we said, we'll bring it down, we'll mark all the stones and we'll put it all back up. And they said no. So it nearly killed the project. And we thought, no, it's just as much a mathematical or a design issue that we have to deal with. And this was our solution. And we had 500 tons of stone on its original structure while we stripped off all the stone, all the structure around, all the brickwork and all the blockwork. And the client used to ring me every single day for about 6 months, about 7 o'clock in the morning saying, Albert, are you sure these 500 tons of stone is going to stay up there until we build the building? And I'll keep saying, yes, it will. And I said, I've got my ticket to South America if it doesn't. But, and the whole thing sits above the Baker Street station line coming through. But then it's actually going through the mathematics of the soil, mathematics of how the ground is going to behave in terms of heaving, the possible slight movement over the period. But again, we're able to deal with it. Moving on very quickly, East Beach Cafe with Thomas. This is my introduction to Thomas Heatherwick, where we actually took the architect's line model and then we mathematically remodel the forms where it was geometrically meets the requirement of the local fabricators, which was Bill Tustin, and he just passed away literally towards the end of last year, a great loss to the industry. Because even though he was the CEO of the company, we actually go down to the workshop and actually bend metal, which was fantastic. And the whole curvature was done by a series of strips using a very old handmade roller to create the whole of this structure and cut and welded. And some of the things we're doing at the moment in terms of pushing fabrication and research is a project we're doing in Sandbach, and where we're using composite materials, where we're using composite materials to span a cantilever, a roof. So if you look at the photo in the bottom left-hand corner, it's got a spine beam, and the roof is cantilevering 20 meters clear, cantilever with glass on 3 sides. And that cantilever 20 meters, and the structure is only 750 deep on one end and 100 millimeters on the other, by actually using composites, which are now materials which are used for aircraft and boats, incredibly expensive, but they're now materials we can use in the building industry, and we do not use it enough. There are other materials which are light, which are thermally much more superior in terms of making sure our energy consumptions are reduced. Again, these are some of the things. And this project is also politically, was also used to temper the flooding process in the area. So yes, I think research is very important in terms of pushing, testing the boundaries and pushing the boundaries. I'm going to go through about 8 major projects, and not so much talk about the project, but talk about some of the issues we have to deal with as designers, where we have to mediate and sort of allow us to sort of navigate the process of making that happen. And within that, you have to deal with all the issues. We're involved in dealing with a couple of islands in the Red Sea, where the issue here is to try and create an industry that is not dependent on oil. Now, it's a big ask in Saudi, but they are actually making the move to say we have to address some of these issues, and we need help and expertise to make that happen. And we're working with Ken Kuma as one of the architects on this, and Foster and Partners. The drivers for us, and this for me is the most important slide, and the drivers for us and for the client, let's be honest about it, is to try and maintain the ecology of the region. How do you do this? How do you intervene? And one of the reasons for this is these are beautiful islands, but they're slowly being invaded by the human race. I do not believe you can stop that invasion. What you have to do is temper it and educate the public to interact in a more softer way without actually destroying the ecology of the area. And what can we contribute as engineers? And for us was how can we create spaces where we're not using any solvent that's going to contaminate the sea, where we're not going to be using concrete in its form, in its liquid form, that's going to seep into the water course. How can we prefabricate and reduce the use of diesel engines, pollutants, and yet still create environment? So first was to actually work very closely with the designers and the team to discuss, a lot of discussion in terms of the vision and how that needs to happen. And then trying to create an environment. These are some of the visions of what I've been trying to create. Try and use a material that actually works very well with its environment, which we were able to establish. We spent a huge amount of time on just pure research for literally months without worrying about the design. And in that research, we realized that some certain form using the shaping of concrete, once it's cured and it's in the water, allows you to actually grow more corals. And that's something we need to do. And then there's also timber of certain typology, like a coir, can actually exist with salt water, coexist with salt water, and yet create an avenue to create the structure we need. So in a sense, as designers, even with the political and the perceived position of the area, this is something that's going to hopefully affect the lives of people and actually create a situation where visitors to the region can actually visit and understand, and there can be more dialogue going on by actually on experiencing the region. In our view, it's important. And I take this from some of the conversation that was had with the late Zaha while we were working with her in Azerbaijan. And then we come to the big global. This is a project that's going on. It's on site at the moment in King's Cross, which is the European headquarters for Google. And this was again to deal with how do you create a first-class headquarters that uses all our knowledge at the moment in terms of creating a sustainable working environment. We've been lucky enough to have done most of the commercial at King's Cross from the early days, and the whole approach of each project we do in King's Cross is always been a massive improvement on the previous. And those improvements, for me, ends up with this project, which we won which both Biaki, BEng, and Thomas won as a competition, the global competition. And we then had to, we were invited as the engineers to do it. But this slide gives you a clear idea of the process. This is a process of creating the minimum footprint of the structure that actually opens up the ground floor, a double height space, because the boulevard, which has been very successful in terms of linking the north and south of the King Cross development and the links across, but also how do we improve on that? And the whole idea of the client and the architect was to actually open up a lot of the ground floor. What that meant was to try and reduce or almost remove all the columns on the perimeter. We were able to do this by actually creating a truss structure at the top on virtually the 8th floor in some areas and the 12th on the others, because the whole site steps. And by doing that, we're able to put all the plant, majority of virtually all the plant in those space, and then use that same space to hang the structure. And we use as much timber. The original scheme would have used every single piece of timber in Europe during its construction, because it's a CLT floor. But we also had to deal with the human existence of how you use the space. So there's also the issue of fire. How do you deal with fire with such a large compartmentation, and also the dynamics of such this element? And this gives an idea of the vision and the ambition of the project. To do that, there's the Victorian approach in terms of having these hangers by just using something that has that works with the area of King's Cross, the Victorian. But also Thomas and Biak were very clear that we wanted to use a sustainable element in terms of the glazing system. It's actually large lowland timber elements. And then we've got the CLT floors, which are then hung all the way to a concrete floor on every fourth story. And by doing that, it then allows us to deal with the fire issue. And even then, the concrete we're using is precast. It's not in situ. We've minimized the use of in situ. So precast, pre-stressed precast concrete. And this is going up on site at the moment. And this is going an idea. So you've got a series of these trusses at 9-meter centers. You've got the cores. And as you can see, it goes from about 22 meters wide on the lower end, right up to about 66 meters. The whole foundation system was already in place for a different scheme. And then we came along. So we had to reuse that in such a way that we didn't have to knock it all down or start again. That would have been really sad, even though they're completely different schemes. And this gives an idea of access going on. For me, one of the biggest research elements and one of the biggest drivers here was that by actually challenging the whole industry in terms of how CLT was being used, was that there's a preconception that you cannot get the dynamics and the noise. You cannot resolve the noise and dynamics issue with CLT floors unless you pour 75 mil of screed on it. And we were determined not to do that because it goes against all our grain in terms of the minimizing the use of minimizing your carbon footprint in terms of the elements of the materials we use. So by actually, and the client was really supportive. So we spent about best part of 18 months testing every single type of CLT in every condition. And not only and testing that with the University of Essex, we were able to determine the performance of how CLT, sustainable CLT works. And we're now basically installing probably the largest CLT commercial floor in the UK, and we are not pouring any concrete on it. But by using new materials and composite materials, we're able to do so to make it work. A huge amount of testing, writing our own programs, taking the data, having to go through it, and doing all the research and processing in-house. This, for me, is a statement that reflects where we all are globally. And I think I sort of felt it was important, having worked with a number of designers with a client from the United States, spent the best part of a year, toing and froing between the UK and San Francisco. And for me, this whole idea, ethnic and cultural diverse companies are 33% more profitable than companies that lack ethnic and cultural diversity. Comes back to the old saying, diversity is not just a cultural or a life issue with the problems of how race are dealt with. It actually has a positive response to what we're all trying to achieve. And companies with gender diverse executive teams are over 20 times more profitable than companies with male-dominated executive teams. So this, for me, is important that our institutions take cognizance of what can be achieved. And I'm optimistic because a lot of the conversations I'm having, and one of our clients, who I think is one of the most progressive clients we have, or a couple of them, are questioning their own position on this and to see how they can improve. And there's a lot of conversation going on to see how we can all contribute, because it's all about contributing. And this was a project we did again with Biaki and Thomas, a massive master plan, looking at 17 domes. Each one of these domes, minimum dimension was 130 meters. We were trying to create a working, almost a tiny little enclosure where people can walk around in very good, almost hospital quality air, but also deal with it as part of the landscape of the whole of Mountain View, and bringing the community into how Google works. And there's a massive amount of research on how you can create a dome or typology of a dome. And we're almost there with kind of materials that can do this, but it's not quite there yet, because you can either do it by inflated materials, but then you're then dealing with conditions internally, which has an impact on human beings in terms of using those spaces. But we're slowly getting to a situation where we can cover large areas and get it to work structurally. And you've got to remember, San Francisco is a seismic, very high seismic zone. So we're in a very sort of sand-filled area. So in a seismic situation, the whole ground liquefies. It's liquefaction. So we went through a whole huge process of dealing with about 8, 9 domes, but there's a few which are not within the mountain, were slightly outside Mountain View. And we took 3 of them up to scheme design, and then we've got local practices who are then delivering them. We're not delivering them. But for us, the research and the thought process and the ideas and bringing that through is important. So Buckinghamshire Fuller, the whole idea of creating a dome in a town or a village or a city is not that far away. But we need now to take a bit of a step and question the amount of energy we require and how we get those energy in a sustainable manner to make things like this happen. So these were the planning drawings. We got planning. A huge amount of development went through over a period of time. And we went from, this just gives you a very simple idea of how the material and fabrication was literally part of the analysis we had to do. And a number of analysis forms and typologies was done, and for glass structure, for non-glass structure, for ETFE, how you reduce the stresses. We went through a huge amount of analysis, wind across the system, relaxation dynamics approaches. And we also looked at the seismic effect on planar glazing. We developed at AKT, rather than a cable system, which is what used for lattice structure, we came up with what we call a grid net, where we're using flats. And it is that system that's been developed locally, where they've gone from flats to tubes. In our view, the flats would have worked just as well, but the local politics in San Francisco and how they work and they deliver the projects had to be taken into consideration. That's a bigger battle. Whereas if this was being done in the UK or in Europe, we would have used a grid net system. Rain analysis in terms of geometry had to be done. This was the kind of environment they were trying to get internally. But also the client was very keen that in terms of the working environment, they need to be able to change the usage over a 3-day or a weekend or a week. And the only way to do that was to get spider cranes and automation and robotics into the whole process of being able to move the floors, create new floors underneath the enclosure. And as I said before, the effect of the different methods of analysis was analyzed to see whether we can get efficiencies and the most acceptable. This is the cable net. We went to the flats. This is the grid net, which for us was to have a series of literally flats, which are connected at nodes, and they had enough stiffness to reduce the amount of tension forces in the perimeter, which meant you're not having to pour tons and tons and tons of concrete into the ground. Even though it's not seen, you're still polluting the ground. So the infrastructure side of things, because even our design fraternity of designers and architects and engineers, we ignore structure that is below ground. As far as we're concerned, if it's not seen, just pour a lot of concrete in the ground and everything will be fine. No, it's not. We cannot think like that any longer. We have to question every single aspect of what we do and how we carry on developing on this planet. This is the end product. That's what we're hoping. This is what it's going to look like at the moment. This is quite a few months ago, because I think it's now virtually completely finished. I think it's now the internals happening. As you can see, the dome was being developed way ahead of the internals. So tower cranes are out. You have to think a different way of constructing using prefabrication panels, So now the internals and everything happens without having to use heavy craneage. Idea Halif, was done in 2012 with Zaha. Some of you are aware of this project, but this is one of the projects we're very proud of. I was personally very proud of. I spent months traveling to Istanbul with Patrick while we designed. The image above is the computer model that was presented to the client. The image below is the final product. And even though at the time when this was all being done, it was a very controversial part of the world, but this was a project that was going to improve the lives of the people in the region. And now it's seen very positively. I was in Baku literally early last year, and it's just fascinating watching the way people interact with this building. And we went through the whole process. We had to break the whole design approach into a series of simple elements, large elements that could be understood in terms of the concrete wall, the floor, the floor plate, the enclosure. And again, it's a seismic zone. How do you create a non-regular? Because seismicity loves regularity. All you have to do is walk through the streets in Japan and some of the buildings in California. You could see they're very regular, very rectangular. How do you deal with a non-rectangular, both vertically and horizontally form in a very high seismic zone? It requires a huge amount of analysis. Go involved in the facade, in the enclosure, by actually writing the software really right back in 2012, which allowed them to be able to tile the facade. And this was given to Zaha's office. He allowed them to change the size of the tiles. We determine, where the specials are, and he's constantly giving the number of. So this program was written, and it tiles the whole building, literally the whole building. So this was modeled by AKT and was used for the project. And it will show you, this is the whole building goes into the model and allowed us to do that. And this is the building. Now, this is fascinating. Coming back to the issue of politics and design and engineering, this is a building where we started using trusses. We designed using trusses. We went through a space frame approach, and we went through all the approaches you can use to create this enclosure. We came back to the solution, that the only solution we believe is the right solution was to use trusses at 12-meter centers. But then politically, we could not get one contractor in the world to actually prepared to go to Baku and deliver our design. And the only people who were prepared to do it was Miro, on the proviso that it was redesigned to work with their system. bastardized approach of this system, which meant a huge amount of the loading on the roof. We had to go from FRC to FRP, and which was, so as designers, we have to be flexible enough to understand the political language or the political situation we're in terms of delivering the vision of our projects. And this is a prime example of that. And this is it going up, internal, the finished product. It's got theaters, exhibition hall, museums. It's basically a multi-public building under one roof. And these are some of the finished product, the spaces. Bloomberg, fantastic building, controversial for some, but in terms of a building that will stand the test of time, will be one of the buildings in the city that will stand the test of time. Very, very strong drivers, one of the most sustainable buildings of its typology, or probably the best sustainable building of its typology, as far as I'm concerned, or as far as I'm aware, in the city and beyond. It's not a skyscraper, it's not a tall building. The issue of St. Paul's was cognizant to the architect. The client was very keen to contribute to actually give back to the city. And part of it was that on the infrastructure side, we had to build a whole new station. So we had to go down 22 meters and create a new station for to double end the city line. So there was, and also we had to deal with historic England. We had to look at, it's one of the sites where the largest amount of artifacts was taken out. We had to take the Mithras from its original position back into, from its new position back to its original position in the basement and put a structure over it. We created a trapezoidal grade where the beams are the shallowest beams you can use for the span, which created dynamic problems which were resolved, and the client is very proactive, and we're now, using dynamic sort of active dampers. So, which is taking technology that's being used in the car industry, in the aircraft industry, and being used, from my understanding, probably for the first time in a building. The other industries see it as standard, as normal, whereas we're so behind in the construction industry that the whole thought of it causes people a lot of problems. But as you can see, 3,500 or so was excavated by hand. I mean, they took out so much artifact that they actually created a small museum within the building. As you can see, the display. And for us, this was the biggest challenge, because this challenge meant that we had to, coming back to research and dealing with also the political situation at the time. The site had 3,000 existing piles, small diameter, very shallow. The usual and the approach from every single infrastructure engineer at the time worked with a serial guide that said you had to test a large proportion of the times, a percentage, so that it can be warranted. And we just said it's just not on. It's just not the approach that should be taken. We know what the profile of the soil is. We know how to analyze parameters from the soil. And this was taken to its highest level, where the client had to bring in experts from the United States to actually review our proposals. And what we ended up with was to say, by disengaging the existing piles from our new structure, those existing piles become part of the soil parameters rather than part of the building parameters, structural parameters, which means our model for the soil and how that will behave had to be developed, not using standard information of how London clay works. This is a set of London clay that has a huge periphery of piles already imposed on it. So we had to create the new properties for the soil, and then we rafted most of the building. And the red piles are the new piles we created, where we have a lot of the piles in the corner is where the new station went down. And as you can see, we saved the client a huge amount of financial gain, but more importantly, from a sustainability point of view, and I think it was one of the first, probably the first time it was done to this scale. The internals, taking the stepped ramp to another level, creating the circulation space. So everybody goes to the 10th floor and then circulates from there. You can circulate through the lift, but most people use the stepped ramp. It's done in such a way with a high sideways, which I thought was absolutely brilliant by the architects, because it allows people on the open work floor not to be disturbed by the movement of people within that space. So it's fascinating bringing movement, dynamic movement into a working space, and they work seamlessly. I think it's brilliant. So you're cognizant of them, but it's not disturbed in the working areas. It's great. And using a sustainable timber structure to create the entrance. Keeping the views of St. Paul's, for a building, it's got fairly tight floor to ceiling height, and the architect was absolutely brave enough and absolutely right by creating a lighting system, even though bespoke, a lighting system that creates even lighting across the whole space when needed. Introducing the old street that was lost in the old Leadenhall building. Now, moving forward, I'm almost over, I sort of believe organizations are increasingly embracing design and engineering as a sustainable solution to improve our health and well-being at work and in our living spaces, while reducing the environmental footprint. For me, this is, and for us as AKT, this is what it's about. And I think it's happening. It needs to happen much faster. And I think for us, it's part of our mantra in terms of doing that. So we go to great lengths. This is one that's close to my heart, where we did this pavilion from a competition, and the client gave us one brief. Please be one of being the top 5, because they actually judge each pavilion. First, second, third, being the top 5. That was his brief. We actually won it as the best pavilion. And the issue here was to use composite materials in a structural and innovative manner. So a lot of testing was done, the idea. But coming back to politics and culture again, this is important. When we presented this to the Chinese institution, they completely rejected it. So much so that it almost became a diplomatic argument between the Foreign Office and the Chinese local, the government of Shanghai, the local Chinese government. And I can remember having to jump on a plane and having to meet the members of the British embassy there, just to talk about this project in terms of the approach. Because at the time, I don't know what the culture is there now, at the time, acrylic was not seen as a structural material. Even with all the testing and stuff we did, not only do we even had it tested independently outside the UK to make sure it would meet the criteria. But anyhow, it worked. But then the issue here, from a communication point of view, we presented the whole thing like an IKEA, and it was built like an IKEA model, using the munchkins. That was fun, actually. Using the munchkins to present it. But a lot of analysis was done where we used acrylic, and understanding resonance of how acrylic resonance in terms of high winds, typhoon or whatever, and the winds, by actually marrying that as a composite with an aluminium tube, we were able to slow down the frequency of movement, which meant, and this was some of the testing regime that was done, which meant we were able to then get it to perform the way we wanted it to perform. And one of the biggest structural challenge for us was we were trying to hit 10,000 penetration through the structure. We managed 60,000. We were trying to get 100,000. We managed 60,000. And in that 60,000, at 100 meter centers, literally drilled the holes at different angles, all computerized. Everything was computerized. That allowed us to then, at the same time, it was also the main structure that held everything together. And this was it going up. And this were the acrylic and aluminum members going in. And it created a beautiful light that goes from the inside in the night out externally, and during the day that goes through the clear acrylic into the spaces, as you can see. And this is some of the internals. And Thomas worked with and the team worked with the World Seed Bank, where they actually cast seeds from the World Seed Bank into the spaces. And this is a sort of drone view of, this is the finished building, the finished pavilion. It wasn't a simulation. This for me is this project for me was the one that tested the whole idea of pushing the boundaries. Very quickly, I'll go through this. Some of you cycle or go past this building every day, built in the 70s, and it deals with some of the issues we were talking about. On the left is the existing building, a 30-story 1974 precast columns, precast concrete structure, tired, empty, was going to be demolished. The developer and the engineers, and they did a due diligence and said you can put 4 stories on the existing. So every single developer was going to demolish it. We were called in, looked at it and said, of course not. How many stories can we put on it? 4? No. I think we started with 8 and then we went on to 12. And 11 was put on plus the plant, so about 12 stories. We did not, running quickly, 11 stories per plant. We did not strengthen any of the columns on the tower, and we did not enhance any of the foundation system. And we added 30% more onto the existing building. Politically, you even got to a situation where Westminster across the river was objecting to the planning proposal, and I had to go present at Southwark to deal with the objection from Westminster. And the reason for that was that everybody thought we were, we were taking the piss or something. But more importantly, the podium building is 6 stories and we added 3 stories. So 50% in the lower section and 30% in the upper section. So we had to deal with not just the politics, but creating this and pre-stressing it. And we also had the tube lines going underneath. And by actually basically pushing the core and reconfiguring how the load paths walk through the building, we were able to make it work. Sheikh Zayed National Museum is on site. This again is to do with culture and identity, process in terms of design. The Louvre is there, and we're doing the national galleries, which are now going up. Falcon, computation. We use MicroStation and Sophistic by creating a model, which we gave to the architects to play to their heart content, but we work within the engineering parameters that allow them to develop the wings, which are now, I think there was an image that was sent to me a couple of days ago to show that the first wings are going up. With the galleries are all hanging, so we took it right through to detailed design, but it's partly been redesigned again because it's taking so long, and circumstances have changed, and the client proposal has changed, but the basement was put in place and was left like that for about, 5 years. This was the latest we saw about 6 months ago in terms of the structure going up. in the middle of a desert, which is now being habited, because when I can remember visiting this site years ago, it was just, there was nothing there. But now it's being developed in a very sustainable manner, I must say, for the region. So this is now the new proposal, is to have it all pretty much more simpler, not so busy. As we, in terms of where we are now as we move forward, I believe this statement sort of sounds true in terms of where we are moving forward. Globalization in infrastructure is associated with high tech in the provision of development. This neurosis ignores all the innovative approaches related to local cultures of low energy emerging nations. We in the West and the UK and America, we are using technology, we're pushing technology to its extreme, and we're going to carry on pushing technology to reduce the amount of energy systems we use. And our energy system is off the scale, we all know that. There are other emerging nations where their innovative approach, where they actually use significantly lower energy than we do, is not being recognized as being innovative. And for me, that's a neurosis we need to deal with, and we need to get over, really. We can learn a lot from how cultures have developed in terms of their usage of space, light, energy, transportation, rather than seeing that we have to impose a tech approach, which in a sense, from a commercial point of view, get used for a limited point of view and then has a limited life. The vessel was to do with creating a space around a huge development and a symbol for West New York. I'm just going to run through this. You probably are aware of this. Our team did a huge amount of work on this. The whole structure itself, the whole form itself is the structure. And we worked with Thomas's team on this, and we had to deal with from walking to dancing. This is, people walking and all the frequencies and using TBMs to make sure the whole thing stays stable. And remember, the whole of this is sitting on a deck. So to give you an idea of some of the structure, it was actually built in Italy, and then basically transported all the way to New York and installed in place. This is a short video that was done at the opening with everybody walking up and down. And from what I understand, it's a highly used space. The New Yorkers love it. And I think this is the final slide. For me, this is probably one of the most important projects which I'm involved with at the moment, which is the National Cathedral in Ghana with David. And this is all about recognizing typologies. Cathedrals, from the dawn of time, place of worship, are always created around the culture of the people and the community that uses it. And that goes for the biggest cathedral, Canterbury Cathedral, our Gothic Cathedral, Notre Dame, and also some of the Byzantine and medieval, both Islamic and old Christian religions. So the whole purpose of creating modern cathedrals and being designed or created in a form that is alien to the culture, to me, is wrong. And that is where I believe the architect, because this is an international competition, won the competition, because it was actually looking at the local identity of worship, kingship, seniority. How is it, and the whole idea of using umbrellas in the prop system, how do you then use it and translate that into a place of worship? And I can remember David Ring says, we've got this ideal, this crazy roof, how are we going to make it work? 0 columns internally. The span is roughly 220, 230 meters by about 85 meters width. Clear span space. The more important thing is that to make sure it can be built locally with the local technology. And that's exactly what we're doing. So the whole thing is spanning in a short direction. It's either trying to push out as an arch, or it's going to pull in as catenaries. And we're able to actually analyze and by linear the columns and allowing the whole thing to work dynamically. And also we're in a seismic region because Accra is one of the few seismic areas in Africa. And this is some of the early images of the internal. There's some more new images now being developed and the external. These are some of the spaces. And this is now on site with a massive podium basement happening underneath. And a huge amount of landscape, the improvement of using local infrastructure, trees and bushes and everything, looking at areas where it worked and then using those to create the design. So and that's it. Thank you. That's it.
Thanks so much, Albert. I mean, that was an amazing talk. And I think you've kind of opened up a lot of issues that I'm sure there are people that would like to ask you some questions on. But I think the value that you've shared in terms of your experience around issues of design and research and how those actually bring people together to be able to be creative for the various challenges and the different scales and magnitude, I think is quite amazing. And it's an unsaid thing probably on the daily, but yeah, this knowledge and thinking about ways to address issues of sustainability through design and through critically evaluating the problems, like how to ask better questions and how to bring people at the table early across disciplines and coming from different backgrounds, I think sets the tone, I think, in a very kind of proactive way to find how we can participate in much larger kind of problems that I think you've outlined very eloquently.
I think we have even, we have a lot more challenges ahead in light of what's happened in 2020. But I think as a fraternity of engineers and designers, I think we do have the skills within ourselves to stay positive and to create a very positive outcome, regardless of the external forces that's been imposed on us, the lockdown, Brexit, Black Lives Matter, understanding how by actually enhancing the internal strength and the knowledge and the research we have, I really do believe we will end up in a stronger position. But we have to take those steps. We have to see it as, as a positive way forward. And it's a very difficult thing to deal with, but I think we haven't got a choice. And I think we also need to, individuals have got a lot of strength. The institutions need to actually, if I'm being honest, they need to get off their ass and actually help lead some of these moves to allow the younger, because I believe what's happened in the States and what's happened recently, both in terms of politics in the States, what's happened recently, and when you look at the issue of diversity, it's been driven by the next generation, the young generation, which means the institutions are going to have to actually wake up and get to the forefront of these issues and help solve it. And very, very few, there's some amazing institutions doing it, but very few are still taking it seriously. The old ways of dealing with design and how you consume design, how you create space, there's a whole lot of conversations going on about what's the next office space, how are we going to deal with transportation, what happened to the infrastructure that needs to go into place for electric vehicles, are we going to stop flying, these to me are all engineering and also design issues. And for me, these are issues that can be solved, but you need people with a vision and you need the institutions to basically get off their ass and lead this process that allows the rest of the people who can then contribute to make it happen.
I think that's really well said, Albert. I would like to open it up. I did get a message from Umar. If it's okay, I will unmute Umar to be able to ask you a question directly, if that's all right, Albert.
Hi, Albert. I don't know if you can hear me. Yeah, very fascinating presentation. Thank you very much for sharing all of that. And I guess a couple of questions more related to the technical aspects, really, of your approach to using the existing piles as part of the ground model in the Bloomberg project. Could you kind of, I mean, without needing to, test every piles, you used a new approach. Could you discuss the technical aspect of that a bit more? And another question regarding the South Bank Tower. Very fascinated again to hear about how you've added this additional space without strengthening to the columns and the foundations. Could you maybe elaborate on that approach a bit more, please?
Yes, I would. Yes, if I'm honest, I was very clear to try and make this this conversation not technical, because I think as engineers, we know how to solve the technical bit. And I mean engineers is a lot as a group, really, and we can work with designers and architects and everything and make that happen. So I was trying not to, because for me there are bigger issues we need to deal with, and there are bigger challenges in terms of creating the mathematics and creating the computational approach is one thing, but for me, that's part of the story. The story here is, how do you then take that and get that to work within the environment, which in a sense, from an engineering point of view, are lay people. They do not understand the technicalities of what you're doing. You then need to then come back to the whole communication issue to allow them to understand it. Once you understand the process, then approvals and everything allows you to do what you need to do. To answer specifically on the technical side, let's pick the Bloomberg issue. There's a serial guide that says, if you're going to use existing piles, you need to test a percentage of them that allows you to connect the building to those piles and warranty the new building, because you're putting a new building onto existing structure. Now, we as engineers have to actually take a long way step back and say, why is that so? We know concrete is a liquid material, and as a material can last 1,000 years if it's done properly. And the lifespan within our codes is probably about 60 years, 50 years, 60 years. And most concrete structure will last 3-4 times that. Yet, we go through a process of removing those elements and putting new ones in, where we're creating a huge amount of carbon footprint. So the whole process of having to test these piles is to do with warranties, to do with insurance companies not willing to warranty. It's not a technical argument, it's a economical and a political argument. As engineers, what we've done in the past is to say, it's political and it's economical. We'll just go for the lowest common denominator. Either we extract the piles or we put new ones in. By challenging those problems, then the technical is easier to do. So by actually saying, okay, if I am going to do a new building and I'm not going to pile it, I'm going to put it onto the ground, do I need to test every single 10% of the ground? The answer is no. Why? Because the ground is the ground. Okay, if I do not connect these piles directly to my building, are these piles part of my building or they're not? They're not. They're part of the ground. So that was the argument we put forward. And as soon as you put that argument forward, you then remodel the properties of the ground with all these hard points, which are these piles. And you find that the capacity of your block as a whole is immense. It's actually greater than the capacity of the original house. So that way we were able to put the building on it. So the numbers you can do, it's not a problem. From an engineering point, the numbers you can do. So that's how we solved that one. But we had to take everybody back to the whole essence of how things should be dealt with. When it comes, that's Bloomberg. When it comes to South Bank Tower, that was a little bit more technical, because the issue here was that this was a building that was built in 1974, I think. So if you think about it, 1974 to 2000, it was roughly about 30 years, But because it was done in such a way that it no longer has a usage that was considered not having value, the only solution that the development side of our business can see from a financial side was to demolish it. So you just look at the amount of carbon footprint by demolishing all of that structure, wrecking all the ground and everything, transporting it to wherever, landfill site, whatever, amount of energy carbon, and then building a number of, I think, got planning for about 5 new domes. What we said was that, hang on, this was a building that was built by one of the most eminent engineers of their time. And at the end of the day, this is concrete. There's nothing wrong with it. Mr. Client, can we repurpose this building? Yes, we can, but it doesn't work in its present form. Right, how can it work? We need more area, right? Put some more on the tower. For us to do that, so you have to get past the social, lifestyle, economical argument before you deal with the engineering argument. So the engineering argument was then to say, right, when this building was designed, because it's a precast buildings on the columns, the core was the element that dealt with all the stability of the building. And the core was then built to a scale and a size that had to deal mainly with the wind loads. Okay, if I was gonna add, so think about concrete. Concrete loves compression, hates tension. So if I'm gonna design a core, my main reinforcement that goes everywhere around it is based on tension, because it can swing either way, not based on the compression. So your compression capacity is huge. Then the second issue here is to do with movement, because to do with stiffness. So the way we dealt with it was to say, okay, if we add 12 floors onto this building and we put all of that dead load into the core, right? We are technically pre-stressing the existing core. By pre-stressing of this extra load, that core no longer goes into tension because it's been pre-stressed by this huge amount of load, which is capable of taking. Which means by then increasing the lever arm, by actually having every single floor, it's a waffle floor, as a transfer element, you're able to then increase the lever arm in bending from the edge of the core to the opposite column on the other side. And you're actually putting less load on it. That's one. Secondly, concrete carries on curing after 28 days. So over a period of time, about almost 30 years, it gained about almost 30% more strength, which means your original design actually got more capacity than it was originally designed for. Why do you want to knock it down? It doesn't make social, commercial, or any kind of sense. And the only people who can actually put that across is us as engineers and as designers. So that's how we solved that one. The issue of the pass, you had underring pass, the tunnels going on in it, was the most easiest one to solve, because if you understand the properties of London clay and how clay works, it's over a period of about 20, 25 years, whatever liquid that actually exists within the pores of the clay dissipates to compensate for the load that's on it. So technically, after about 30 years, is it 30 or 60 years? 60 years. That's how long it takes for it to settle. It's about 60 years. You could actually put the total amount of load you had right at the beginning of an existing structure on London clay, and your settlement will be less than what it was in the original and be able to carry the load. Because you're dealing with heavily over-consolidated clay. So that's the technical aspect of how we're able to solve this. By going back to first principles, because the codes deal with the lowest common denominator in terms of design and development. And if engineers can actually look at the appendix and go beyond the code, no problem. Sorry, I've gone on a bit on that answer.
No, I think that's great, Albert. There are a couple more questions in the chat if you
yes, please.
Enough for it. There's a question from Miguel that is asking if you could explain in more detail the solution for the CLT slabs at Google headquarters in King's Cross.
Oh, that will be very difficult to explain in single terms, very simply. Basically, we found that the data that exists at the moment from all the manufacturers and providers of CLT is not accurate, it was wrong. Because when we took all that properties and data and put it into our model, and I can see why engineers, it actually throws all the figures were all over the place. It just doesn't work. Your response factors were incredibly low in certain areas. So the way we looked at it was to actually design a building and looked at the areas where we've got your loose, your stiffnesses, where we got CLT, where we know the corridor spaces, your sitting spaces. A whole analysis was done on the movement and the possible reorganization of the spaces. So that was one. The second thing we had to do was to then test the properties of the material on various conditions. In installation, wet, dry, walking speeds, running speeds, stilettos. We went through the whole process. The frequency of walking, running, strutting, and then calculated the response factor for all of those. And the data we got back, we then had to write, because the amount of computational time required to do each one of this is just off the scale. So we actually then write our own analysis to actually did a pre-analysis, pre-computational analysis of that data before we fed it into the usual analytical packages we all use to calculate response pattern dynamics on floors. And the whole process took us 18 months to get to the answers we got to. But we could not rely on any of the information from the manufacturers. And we had two other engineers who were brought in by the client as experts to actually look at this and could not come to this. But we were adamant and we stuck to our guns as the lead, as the main consultant on the engineering, to say from a sustainability point of view and carbon footprint, we cannot go down that route. It's just not right. Why should you be pouring concrete on timber? In my view, you must really increase the timber from 75 to 150, put some reinforcement in it, and then the CLT is just very expensive shuttering system to look at. Doesn't make sense.
Miguel was asking about the pros and cons of CLT, in your opinion.
I'm not a big fan of CLT because I sort of feel as time develops and as we move on, we've got to move beyond CLT. There are other composite materials you can do with wood where you can allow you to create better servicing route and lighter panels that allow for lightweight prefabrication that reduces the amount of infrastructure you need for your prelims, tower cranes, etc., that allows us to build faster, quicker, less carbon footprint. But the industry still need time to get on board, and research and the fire industry is the one I have a problem with at the moment, because very few fire consultants are prepared to look at fire engineering. They look at precedents. And what we need to do is we need to be a bit more sophisticated about this issue. And in my views, I preferred it when we had the fire brigade involved in the whole idea of fire certification. Because when you bring these guys and sit them around the table and you go through the process with them, they will tell you where the risks are. And then as soon as you mitigate those risks, then it becomes a much more dynamic approach in terms of fire. And they're the people who can deal with it. Right now, we have a lot of fire consultants, and there's some really good ones out there who just look at what the code says and says, no, it has to be this. No, no two structures are the same. And for me, those are some of the issues we need to deal with.
And Albert, there's a two-part question from Michelle Collis. I'll read it out to you. I'm interested in how you would deal with the process in developing countries, like the tents and arched dome structures with low-tech passive heating and cooling, and then interpret that in today from the concept.
Perfect. Well, very, very good question. I think it's probably a very good question. I mean, we're working in Accra at the moment, absolutely amazing team of people out there. And this process of thinking that we are imposing an approach to them is completely wrong. It doesn't work. And I've spent a bit of time across West Africa, Gabon, Nigeria, in parts of Nigeria, Ghana, Sierra Leone in the past, and we're doing stuff in Dakar, Gambia, along West Africa. I spent time in North Africa, Libya, Morocco. We're doing some work in Rabat and all of that. And then the Middle East, Egypt as well, and then a bit in South Africa. And the technical ability and the ability to work with computational is not a problem. The problem you have is the issue that a number of the infrastructure, they have no choice. They have no choice but to use come from the West. And because they come from the West, they have to then take something that works very well for them and then try and make it work with components that are coming from overseas. What we've tried to do in Ghana, and I probably showed a Villaggio, a tower, the tallest residential tower in Ghana. We were the engineers for it. And I can remember talking to the client, who's a very good friend of mine now, when he came to London and said, I want to do this tower, and I'm not sure we've got the skills and everything. I said, of course there is. We will look at it. And the first thing, if I mention to any engineer that I'm going to do a tower, 25 stories or more, the first thing they say is, and also in the seismic zone, is you got a pilot. First point of, so the piling rig we use for tall buildings in the UK and in the West are huge monster of equipment. And those equipment can only be maintained and can only be organized by an infrastructure that is based overseas. Just think about the carbon footprint and economics of going to and fro. It doesn't work. So how do you work with the local and make things work for buildings like the thing? On the tower, I just said to the client, I said, you need a bigger piling rig. He said, can we buy one? I said, no, you cannot buy a huge piling rig for just one development. It's just a waste. So we then decide to, as a practice, to look at where tall buildings have been designed without piling. So we end up with a caisson system where we use 2 levels of basement, tied in, and we put a 25-story tower onto that. And we said to the client, you cannot do your externals for over 6 months. He said, we're not going to get there over 6 months anyway, because your settlement is going to be in the region of 50 millimeters. If I mention 50 millimeter settlement in London, I'll get sacked by a client, by the client. But in an environment like that, it's not a problem. So it works. So we're able to do the tower, even though it's a seismic zone. All the numbers, the mathematics and the thing, well, it's easy. And on the cathedral, everything you see in there is going to be done locally. And the steelwork, and we did a small tower in Gozo in Malta years ago. And we also did the first commercial building in Cuba, literally 25 years ago, when Castro was in power. And the only way we're able to do is to say to the locals, show me how you weld steel. Show me and let us know the capacity of the structure you use. They're creating beautiful cars in Havana. They're creating beautiful technology, reuse. It's absolutely amazing, the World Heritage Site. They're able to do with their technology. So what we had to do is plugging into their methodology and using our skills, using their methodology to make it happen. So for me, the overarching approach is that once that is in place, the numbers and the thing happens.
Thanks, Albert. What I was also wondering, because we're working with almost like Khoisan, so it's like structures of the arch domes and how they're bent, and then working with the local garage guys who do the steel. And I just thought it would be interesting, like you were saying, getting these local, like the process of firstly assembling a skill set, and then also what I thought would be interesting is the scales were then changed and say made larger, because at the moment I'm trying to combine sort of like carbon with it. So I was just also looking at the potential of this carbon light materiality that allows for transport within these more local areas, and how if somehow in a way there could be, I'm quite curious as to closer collaborations and participations, and also just where if there could actually almost be a manifesto or a guide made, because I was looking at the Chomsky-like approach of data, how sometimes data is actually lost, or if there's a small problem put into data, it's then exponentially made worse. But yes. Rather how, so rather how using like you've been using actually these principles of local ecology, testing that, reevaluating. So not using your traditional ones, but actually incorporating ingenious ones where there's a very sensitive application to local conditions, and then that's brought in with ecology, which also allows then the question of biomimetics. Yes. But then I was just kind of wondering, process-wise, that's what at the moment I'm trying to make we are making a structure for local shacks and local interpretations of informal structures, but I wanted to cross-weave this. And so I was just wondering if there was any part of your process, particularly perhaps in the Ghanaian one, where it's used, or alternatively in one of my projects at school, which I was very happy I managed to get up to 1 to 10 water gutters and stuff, where I just used very basic ordinary house building, like the typical little triangle housey, and then kind of moved it around like a cube and crafted it with the African weave.
Absolutely. That's what you got to do. You're absolutely right. I think you got to do that. And I think, just to give an example, this 25-story tower, which we did in Ghana, we did not use any table form. Every tower that's been built in modern times, you use formwork tables that comes out up to the next one. That's the way towers are built. We did not use one table form. And I can remember while we were designing, the client was saying to me, I just see a building that's going up, it's about 6 feet. They've got this amazing table form they're using and everything, and they've imported it. I just said to him, no, we're not doing that. Yeah. And we had this huge argument. That was me. And it wasn't as if I was being because we as the designers are the one that have the skills to actually take this process, and help expand it, but actually me putting my foot down as the engineer to my client. He was then interested in how we're going to do it. And I can tell you exactly how we did it. I said to them, do you have any precast, light precast? They said, no. I said, tell me what size precast industry you have. They said, you can get, the 65 by 100 lintels, door lintels. Yeah?
Sure. Yeah, it's amazing.
Yeah?
Wow, yeah, just simple composites and rectilinear can become curvilinear.
Exactly. So I said to them, we're going to go to that factory and we're going to get them to do it. Rather than cutting it to the door widths, we want them to do it to 3-4 meters, and they deliver it on site. And you don't need any crane. There's a lot of labor. The guys, and they literally lined up a series of, I'm not joking, concrete precast lintels, cheap as chips. Line them up, prop it underneath, and they did something which I've never seen before. Then they literally got sellotape. I'm not joking. White sellotape. And they just tape in between the gaps in between each one. And then they drop the bars in those spaces in one-way spanning. And then they pour concrete on it. And it worked just as well as any other reinforced concrete with all the fanfare we do. And they built the whole thing up there. And the finish looked absolutely amazing. But they end up covering with plasterboard to create internal. And for me, they should have just left it open anyway. But anyway, that's a thing. So what I would suggest to you is that you need to dive and understand the local build approach where you're trying to do this. Because there's nothing saying you cannot use bamboo or local timber material, whatever they use, and template it. I'll give an example. You probably know about the, was in Peckham. Yes. Peckham Library.
Yes, yeah.
Those are enclosures in there. Yeah. If you've ever been in there. That was done. Late Will also did it, and we said we needed drawings. And basically it came to us with a box with models of it. So we digitized it. And the only way we were able to do it was to use timber pieces with the then profile cut, right? So we did all the geometry, and it literally just laminated LVL timber, and the developed, and then we just used literally 3mm ply stapled in 3 layers over it to form the curvature. Now the contractor said to us, "Oh, I'll pay you some money to use your big printer to print each of those templates at 1:1." So he paid us. We printed all the drawings at 1:1, and all they did was to put the LVL panel on in a shop floor, staple the drawing pieces on it, cut a staple on it, and then got a jigsaw gun and cut it, and then fix them together and create all those freeform curvature. So there's loads of ways to solve these issues, but you have to talk and be prepared to immerse yourself in terms of how the local people do what they do and how they do it, and then put, computation, engineering around that, and you solve the problem.
But I think that's a great way to bring the conversation to a close, almost in the spirit of Eladio Dieste and kind of strategies of really working in a much more immersive way with the specificities of the problem to kind of realize those ideas. And I think you've made the conversation, I think, very accessible also to talk about technology as something that's very human in the spirit of actually making these ideas possible, bringing people together to work on it. But I think also the purpose of your talk also to shake up a bit what you spoke about as the fraternity and the institutional kind of limitations, and enable people to really engage in a way that foregrounds creativity to some of these challenges that are ahead of us, I think is a perfect way to bring to conclusion our first day of a review, which continues tomorrow. And of course, I would like to invite everybody who is interested to follow the conversations of the jury, of the thesis students, of Albert's, myself, and other colleagues. And I think you're going to have to give another talk, Albert. We're going to have to be able to get you back to do this. Obviously, it's a testimony 2.5 hours kind of later, how much, that there's an audience and a lot of questions. It's a very valuable discussion, and I'm very pleased with the generosity and accessibility of everything that you spoke about. I see it from a very personal perspective because we work together, but I think it's very important for the community at large, both architecture engineering and beyond to be able to have these discussions. So I just want to thank you, and I wish there was a way for everybody to thank you with applause and all of that stuff, which isn't a caricature of these Zoom kind of clappings. But I think it's very meaningful, and I hope we do it soon.
Yeah, thank you very much for inviting me to give this lecture. And I just hope, in light of the very difficult times we have, that people should try and stay safe, and also the fact that we should, I think we should give our thought to some of the people we lost, but actually moving forward in a very strong, strong, positive, challenging manners as designers, students, engineers, and I would just say is that I think people got to understand that you go into this profession, either as an engineer or as an architect, because you want to contribute to the environment. You want to contribute, and I just feel that the institutions should open it and allow everybody to contribute and deal with the challenges we have. So yes, thank you very much. And hopefully, I'm looking forward to joining the review tomorrow.
It's a beautiful and very needed message, Albert. So I thank you.
Thank you very much, everyone. Thank you.
Thank everybody for joining and for being with us. And we look forward to be able to continue the conversation in another form, one way or the other.
Thank you.
Thanks very much.
Cheers. Thank you. Bye.